Hi, in this video, we will look at additional concepts of TLS encryption in MySQL Server. In the past video, we have seen how we can establish an encrypted connection to the MySQL Server and communicate with it in a secure fashion using different SSL modes. For us to establish an encrypted connection, there are certain criteria that needs to be met by all the parties involved. That is, the client, the MySQL Server, and the server's operating system. The server's operating system, the client, all of them, they needs to follow the same TLS protocol and same SSL or TLS ciphers. Only then the connection will be established. Say for example, if the client makes use of TLS version 1.2, the server should be accepting connections on TLS version 1.2, and the server's operating system should also be accepting connections on protocol TLS version 1.2. Not just that, the ciphers also should be same. So there are two criteria, the protocol and the ciphers. They both needs to be the same on every side. Only then the connection goes through. So we have seen these are the ciphers for TLS version 1.3 and these are the ciphers for TLS version 1.2. Imagine if the client makes use of this cipher and making use of TLS version 1.2, the server should be accepting that cipher and the server's operating system also should be accepting that cipher. Only then the connection goes through. Basically, a connection should be using the same TLS protocol version and also the same cipher. So we also saw a different set of variables that can be set at the client side and on the server side. Imagine a need to change any of these variables. We can reboot the server and bring the new values into effect. But if we don't want to reboot the server because of the downtime issues, then there is other way for us to bring the new values into effect. Say for example, this is our MySQL server. MySQL 9.3 Enterprise Edition or Commercial Edition. And currently it is only supporting TLS protocol version 1.3. Imagine a need for us to change this to 1.2. Imagine a case where the client does not support TLS version 1.3. And so we are forced to modify on the server the TLS version to be 1.2, and the host operating system of the server also supports TLS version 1.2. So now we need to change this TLS version variable on the server side so that it accepts TLS version 1.2. And for that we can modify this variable value to TLS version 1.2. But before that, I want to show how we can see the current TLS context related variable values. And for that, there are two ways: show status like. Okay. So the current TLS version. So for every variable that we said, there is an equivalent status variable which shows the current context value for the TLS. So if we see the SSL current TLS CA, for TLS version, the equivalent status variable is current TLS version, SSL cipher, current TLS cipher, and TLS cipher suits, current TLS cipher suits, and similarly for other variables. So going back to our use case, we want to modify the TLS version on our server from TLS version 1.3 to 1.2. Okay, so and we see here currently the variable value for TLS version is 1.3, and the current status also shows that it is only supporting version 1.3. Let me modify this so that it supports version 1.2. We modified the TLS version value from TLS version 1.3 to TLS version 1.2. but the status would still show the same TLS version 1.3. Now there are two options. Either we can reboot the server so that the new value comes into effect, or if we want that to happen dynamically, we can reload the TLS context using this command. Alter instance reload TLS. This reloads the TLS context so that any new connection would make use of the new values that are set. So now if we see show status like TLS, previously it was pointing to TLS version 1.3. After the reload, it became like TLS version 1.2. So to modify the TLS context variable values, not just modifying them, and to bring them into effect, we need to run this command alter instance reload TLS. This is also useful in another scenario. Imagine our certificate is expired and we get a new unexpired certificate. So let me show that. This is our certificate, and imagine if this is expired today and we get a new certificate and we place it in the appropriate location in the appropriate name. And if we want to make use of the new certificate without rebooting the MySQL server, then also we can make use of the alter instance reload TLS. So that is one more use case. Apart from the show status variables, there is also one more way where we can see the current TLS context values. That is by making use of this TLS channel status table in performance schema. This also shows the interface and the current property values for that interface. So currently the TLS version being supported by this interface is TLS version 1.2. So there are two ways. Either we can make use of the variables, show status like variables, or select star from performance schema dot TLS channel status. So both ways we can make use of to understand the current TLS context variable values. Say for example, we set this to TLS version 1.2 and TLS version 1.3. The status still shows currently it is supporting TLS version 1.2, and the variables will show both. And the variable shows it is altered to TLS version 1.2 and 1.3, but the current context is still supporting only TLS version 1.2. So let's reload. Now it is supporting both the TLS version 1.2 and 1.3. So I also want to talk about the protocol negotiation, meaning now we have two protocols that are being supported, 1.2 and 1.3. And just for the sake of ease, and under version 1.2, these are the protocols that are supported. And 1.3, these are the protocols. Just for the sake of ease, let's call them as A, B, C, D. And this one says X, Y, Z. So now for an encrypted connection to happen, it starts from more secure protocol to less secure protocol. So initially it tries to make use of version 1.3 and it checks for the ciphers. Say for example, we call the ciphers as X, Y, Z, and the client makes use of cipher X, and server makes use of X, Y, and server's OS supports X, Y, Z, all the ciphers. Now we have at least one cipher in common, X, 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 at all the three levels, at the client level, at the server level, and the server's operating system level. So the connection makes use of 1.3 and goes through. But imagine if the client tries to make use of Z, which is not supported by the server, then the server only supports X and Y. So then the connection can't make use of version 1.3 encryption protocol. Now it has to fall back to less secure version 1.2. And the same thing happens. Here it goes and sees if at least they have one cipher in common, which is supported by client, the server, and the server operating system. Then the connection happens. So this way the connection happens from most secure protocol to less secure protocol. Not just that, if we have a primary and replica, and we can have the encryption variables set at the primary side and at the standby side. And for the replica to interact with the primary, you can have that interfaces variables also set using this option. Source TLS option in change replication source to statement. You can make use of this setting and set the variables for this interface also to connect to the primary. If we want to connect to the standby, then these variables come into picture. And similarly, for a group replication use case, we can set the variables at each server, and also a server in a group replication can act like a donor or a joining member. So in the case of donor, the default settings apply. And in the case of joining member, you will have to make use of these variables and set these variables. So you can set the TLS version or cipher suits or SSL cipher suits. You need to make use of these variables. Also, if you want to ensure that every connection that is getting connected to the MySQL server is an encrypted and nobody should be able to connect without an encrypted connection, then you need to make use of the require secure transport is equal to on variable on the server. Once you set this, then the server only accepts encrypted connections. And if anyone tries to make use of unencrypted connections, it would fail. But just be careful, even for taking the backups, everything makes use of the encrypted connections. You'll have to ensure that you have tested everything before you make use of the require secure transport is equal to on. So let's just try to set this variable require secure transport is equal to on. Currently it is set to off. So we will be able to connect to this MySQL server even with an unencrypted connection. Let's try to set this to on. So it is on now. Let's try to connect an unencrypted connection. So we are connecting as user 1 and we're setting SSL mode as disabled, the protocol as TCP. So we're asking it to make use of an unencrypted connection through the user 1. Let's see. Connections using insecure transport are prohibited while require secure transport is equal to on. So we can only make encrypted connections. It shows the cipher in use. And there is also one more way. We can create a user and we specify require SSL or require X509. So that way, if this user tries to connect to the MySQL server, it should make use of an encrypted connection. We are basically setting this thing at the user level. So the connections from this user must be an encrypted connection to the MySQL server. So let's try to check that as well. Let's try to create the user with a require SSL. Create user2, the red percentage, identified by password, require SSL. Okay, I need to be as root user. Now let's try to connect with this user from a Windows machine. Username is user2. Username is user2 and SSL is required. Now the connection is through and it is making use of this cipher. SSL cipher and SSL version. So it is making use of an SSL connection. Now let's try to edit this thing and see if we can try to make an unencrypted connection. Okay, now it says access denied for user. So we can't make an unencrypted connection for this user because it needs an encrypted connection only. So this is basically using the preferred mode and it is through. So at the end, we basically reviewed these two scenarios, ensuring that every session that gets connected to the MySQL server is encrypted through this variable. If not, we can set that encryption requirement at the user level as well by creating the user with require SSL or require X509. We have seen this thing, require SSL. We are forcing the user to connect to the MySQL server with an encrypted connection only. And that completes this video. Thank you for watching.